Welcome back to the channel. Today we're going to be exploring a powerful tool for local data analytics, DuckDB. We'll be doing this directly in Visual Studio Code using standard Python files. If you've ever needed the robust power of SQL to query large local files without the overhead of a full database server, DuckDB is your solution. It's incredibly fast, runs right within a Python script, integrates seamlessly with your existing data workflows. At its core, DuckDB is an in-process columnar SQL OLAP database. It's a lot. You probably want to know what that means. I would want to. So in-process just means it runs directly within your Python application. There's no separate server to manage, no network latency. It's designed to be embedded, lightweight. Its columnar storage is highly optimized for analytical queries, enabling lightning-fast aggregations and joins. SQL OLAP means you get the full standard SQL power for your analytical processing. OLAP is an online analytical processing engine. All right, so let's get started. Open your VS Code. You're going to see that I have DuckDB, pandas. Get rid of notebook. I was messing with that earlier. So you can see that I have DuckDB and pandas. And that's all you're going to really need here. So I have created a virtual environment. I have activated a virtual environment. And then I am going to do pip install -r requirements.txt. Give it a second. Cool. Give a little more in a second. If it goes too long, of course, I'll pause the video. I try to not do a lot of pausing and editing just to make sure that you guys see what I'm doing. I think there's some benefit to watching somebody troubleshoot or having them think out loud while they're troubleshooting, so that if you run into some of these problems, you'll know what's going on. And if you don't run into the problems, you can fast forward the video past my little problems and pick back up where I left off. Now, if it gets too far in depth or something's really not working, I'm definitely going to cut that out. I don't want you to have to sit an hour and a half through a tutorial that, is really 10 minutes just to get through all of my troubleshooting, my setup. But other than that, I try to do this on the fly as much as I can. Okay, so that saves. So I have DuckDB in here. Let's make sure my import works. I'm going to import DuckDB, and I'm going to import pandas as PD, because do we ever import as anything else? Right? We just call pandas PD for now until the end of time. I'm going to structure this like a regular main file. I'm going to ignore everything that the thing's doing right now. I'm just going to do pass as a placeholder, and then I'm going to do the if name as main, and then I'm just going to call main, and then I'll put all my logic kind of up here as we build this thing out. You'll notice that sometimes I accept my suggestions, sometimes I ignore the suggestions. It depends on what kind of mood I'm in. So you have two main options: an in-memory database, which is temporary. It's file, or you could use a file-based database for persistence. For an in-memory connection, we're going to start there. Okay, so I've already imported DuckDB. I'm just going to do con equals, I'll take that. Okay, so now I have the connection. I'm not going to create a table right now. I'm going to do, let's do this neatly. I'm going to query the in-memory database with like a 1+1 or something. And I'm going to convert it to a data frame just on the results automatically to show you how easy it is to get something back and make a data frame. So I'm going to call this data equals con dot execute. I think fetch df works. So select 1 as A, 2 as B. And I'm going to do that. Down here, it's telling me I want to print the data. So I probably want to print the data, which is fine. I'll accept that. Okay, and then I'm going to save this file Maybe I'm going to save it. There we go. And then I'm going to run this file. So let's do that. Let's do a run and debug. Sure. Let's add some Python extensions. I used a fresh, clean profile for this tutorial. And so I'm going to have some fun here with configuring it. So I used the Microsoft normal Python debugger, Python package. Some things come with it, which is perfectly fine. It's kind of what I normally use for my workflow. So I'm going to go ahead and try to run and debug with the Python debugger, this Python file. And I'm not going to worry about that right now. Cool. So I printed it out right here, printed the data frame. So what I did is I created an in-memory instance of DuckDB, right? It's really good for analytical work, for, think about your EDA, your exploratory data analysis. When you're doing EDA, you want to read in sometimes large amounts of data to check it out. And sometimes Panda chokes on it. It may take a while. I've seen, read in 10 gigs of data, 30, 45 an hour. And you really don't want to do that. So you can use DuckDB to query directly from the files or go straight in memory and just load something in memory really quickly. It's kind of the power of it. So it's one of my tools for exploratory data analysis. It also has some other good useful purposes. I use it in workflows with DBT and Apache Airflow, but you guys will see that in future videos. I don't want to give away all of my secrets up front. So that's in memory. I'm going to go back here. And now we're going to do a little more file-based. So we're going to change this up a little bit. I'm going to get rid of all this. Actually, I'll keep the same connection because it doesn't matter. I'm just swapping this out. So I'm going to do DuckDB.connect and now database. I don't even think I have to do that either. I think I could just put the name of the file in here. Let's try to make a shortcut. Let's go, I want this to be called DuckDB or duck.db. How about that? Can I do that directly? Maybe, maybe not. So let's rerun it. Run and debug. Hit the rerun. Let's see if it blows up. It printed just like we did before. But now you have a nice little duck.db file here. I used to name them .duckdb just for convention so everybody knew what it was, but you really can name it whatever you want. I found that out accidentally. So when you're connecting to this, now I have a true database sitting there that will kind of just work, right? It'll kind of automatically, I could add things to it. I could take away. It's kind of like SQLite, but kind of an OLAP version. Now what I want to do here is, you'll see part of my little finder pop up. I'm going to grab a file and I'm going to pop it over here. We're going to query directly from the file. So I have a little small data lake-ish setup over here where I have some data. And in my setup here, I'm going to grab some CSVs for let's see, I have some samples here. Let's call it currency CSV, and let's go ahead and drag it in here. Okay, as you can see, I just have a dump of some currencies from around the world, symbols, names, and all the things in that currency CSV. So what I'm going to do now is I'm just going to select star from, let's do a currency.csv. And there's some tricks here. I think I have to do read from. We're going to find out if this does it directly. Semi-new to DuckDB. Semi-not. Look, I just did .df, so that gets my data frame. I'm going to save this. Let's go ahead and run it. I like to play around with different ways to do it. Just to have it, right? And look, I selected directly from that CSV. Didn't have to read anything, do anything. There's no create table here. I selected star directly from a CSV and converted it to a data frame almost instantly. And now you have that. The beauty of this is if I had a JSON file that had something that I can join to this, I could select from the CSV file. I could select from the JSON file. I can join them as data frames and then output them to something else. Maybe I want to output to Parquet. But now you don't have to worry about, oh, I have a JSON file and I have this transactional database, a Postgres or a SQL Server that I want to move my data into to query. How do I convert JSON to, transactional database? Do I really want to? Because it's semi-structured data and I don't want to move it to a structured data format. So I can just leave it in my files. I could do this with Parquet files. As a matter of fact, I have a Parquet file. Let me show you, because Parquet is not human readable, so it won't let you open, but I could play the same game with the data frame. I did not mean to rhyme that. That was kind of accidental. mtcars.parquet. Now, it might tell me I need another library here. Let's see what happens. Oh, there you go. Now I have Parquet data as a data frame. And I just did a .df here at the end. Not doing anything really crazy. But now I could look through that mtcars Parquet file. And in theory, I could join that to the CSV if they had a common key. And if you'll notice, I'm not saving this anywhere. I'm not creating a table. I could create table as blah from mtcars Parquet, and that'll give me a table in my OLAP database, and then I can query that table. As a matter of fact, I do that if I'm doing medallion architecture. So if I'm doing bronze, silver, gold, my bronze is going to be in my lake. My silver may spend some time in DuckDB temporarily, right? I may do views on DuckDB and then persist my gold in the data lake, right? My gold might be in Snowflake, but I get to save the money I'm spending on a big data warehouse here on this in-process OLAP that gives me speed and agility without any extra cost, any extra overhead, any extra reads, any extra connections to worry about, right? So one of DuckDB's most powerful features for data engineers is its ability to query various files of formats on your local disk just using SQL, right? You don't need to load into tables. You don't need to do anything. You literally just query it right off with the same SQL that you've been using daily. So let's say you're a data analyst and you have SQL in your back pocket. You have some, you have some Python. You got pandas. You got NumPy. But really your bread and butter is SQL. That's fine. Come in here to DuckDB and play around. You don't have to load anything in. You don't have to do anything special. You don't have to worry about the ingestion layer, any of that. You come in, play around with SQL, query directly from files, do all the things, do some EDA without really having a lot of the overhead that you need for EDA. You can even do complex joins across the different files, like I was saying earlier, right? And just format it right in SQL. Imagine joining a sales CSV with customers JSON. And then you enrich your data with something from an API, right? Who knows what you're having. In the modern day data architectures, you're pulling data from everywhere. And so basically, instead of standing up this little mini warehouse, you could just drop all of your files in a lake, query directly from the lake, do analytics on the lake. DuckDB does all the heavy lifting, and it doesn't take a long time to load everything in. It's highly optimized for zero copy integration with pandas. Means you can fluidly move between Python data frames and DuckDB SQL engine. So again, you could take a pandas data frame that's already in your script's memory, query it directly using SQL through DuckDB as if it were a table, right? You can do that where I can actually create this data. So I have a data frame here, right? This data frame is Parquet. So let's try this. Let's say my con.sql. And I'm going to go over here and I'm going to select star from data. Why not, right? What do I have down there? What's in my, do I have an MPG? Yeah, well, MPG is greater than 20. And then I'm going to do that also in a data frame. So I should probably save this as data. And then I want it to mean something greater 20. And then I'm going to print it. And let's see if this works. All right, let's see if I can select straight from this data that I have here and filter it using SQL. Because maybe I don't want to use Python. Maybe I'm not that good in Python. Maybe, it's my bread and butter isn't that. My bread and butter is SQL. And look, I have again, MPG, if you look down here, is greater than 20. So I can take any pandas data frame that I already have in memory. So if you give me a Jupyter notebook and you're doing this analysis and you have all these data frames, that's fine. I'll throw DuckDB in there. I'll put SQL on top of it. I'll get that query speed and the power of DuckDB. And then I'll just use my SQL. And I mean the SQL that I have, not actual MySQL as the type of SQL, right? So yeah, that's really a lot of what I want to show on DuckDB. It's fast, flexible, brings the power of SQL to your files without any server overhead. Ideal for rapid data exploration, building efficient Python workflows. If you found this quick start helpful, hit the like button, subscribe to Developer for more data engineering insights, and let me know in the comments what other tools you would like to see next. As always, thank you guys for joining, and see you next time.